So it says medians XA, YB of triangle XYZ are perpendicular. If angle XYZ is 90, so one angle of the triangle is 90, I can immediately recognize. And a side is given, just a sec. So a side is given, so and another side is asked basically, right? So this is one of the cases where it is not obvious from the question that coordinate geometry is to be used, right? And that is why I put this question here. Like there are no coordinates given, there is no like mention of slope or angle between lines or anything like that, right? So there's no direct hint of the thing that okay, you have to use coordinate here, right? Which means that if a general person sees this question, they'll start off on a geometric route for this question, and which will work also, like which is definitely there, and it will give you the correct answer. But coordinate geometry, the beautiful part of coordinate geometry is that a lot of questions on geometry will get simpler if you just use coordinate geometry. So before even we start this question, right, let's just like make a very strong mental note of this, that whenever there are diagrams which are simpler to sort of to analyze, for example, rectangles, squares, right angle triangles, that are sort of simpler. And when by simple, what do I mean? Like it's easy to assign coordinates. Like for example, if in a rectangle I know that the sides are 5 and 3, I can assign coordinates. I can assign this as 0 0 5 0 5 comma 3 0 comma 3. I can immediately assign coordinates, right? So even if the question does not like mention coordinates, I can simplify a lot of questions, and believe me, it works in a lot of cases wherein the figures are like friendly of sorts, rectangle, square, right angle, triangle, etc. And you can assign some of the coordinates and you can solve that question reasonably quickly. So always like whenever you get questions on these sort of quote unquote like good figures, right? So if you're not able to figure out a geometric route, always like keep in mind that coordinate route can also be explored. So for example, in an exam setup, if like in the first 1 minute you're not able to strike like what is getting used or something, then you can immediately start like exploring at least that okay, can coordinate geometry help me solve this question, even if the question does not look like a coordinate geometry question. For example, let's take any random yes, and say this side is extended and something like this is wrong. For example, like you know the sides of 6 and 8, and you know this length of 2, you're asked to find this length. Let's complete this also anyway. You're asked to find this length. Right now, a geometric way to do it would basically revolve around similarity, right? That okay, this is 6 and this would be 1 by 4. So this by this you can find out this would be like x upon x plus 6 would be 1 by 4 and all of that, right? You're getting it right. So basically then this would be 2 and then you figure out Pythagoras and stuff. That is a geometric way to do it, which is perfectly, it will give you the correct answer. The method would work, you will be able to get to the answer, but it may take some time because there's similarity, there's Pythagoras and stuff. So the easier way to do it would have been quickly like starting off this question with 8 comma 0, 6 comma 8 comma 6. Then this is 2 units. So basically this is 8 comma 4. This is 0 comma 6. Okay. So now I know that this line, this particular line is, so 8086, this is nothing but x equal to 8 line, right? So this point would be 8 comma something. This line is x equal to 8, right? This line I can find out. This is 0 0. This is 8 4. So clearly this is x equal to 2y, correct? Like this is 0 0. This is 8 4. So you can immediately see that this line is x equal to 2 into y. Okay. So this point, what would this point be? Okay. Coincidentally here, like since these are random values, it's like coming to be 8 comma 4 here as well. But okay, this should not be 8 comma 4 actually. This is my bad. This should be 8 minus 2 6 comma 6. This should be 6 comma 6 here. So then we know that this line is x equal to y. So this would be 8 comma 8. Correct. Just find this distance then. So this will be root 8 square plus 8 square. Simple enough. So just mark the coordinates and you're done. So essentially you reduce the working in such questions, and actually like it has obviously, like if you see the official solutions or something like this, they would give the geometric route. But if you really think about it in figures like rectangle, right triangle, etc., coordinate can also be helpful. Not in all cases, but in some of the cases definitely, yeah. Especially when things have to do with sides. If there were like angles into play here, etc., then obviously then geometry, like when I say geometry, I mean the other traditional geometry would be the way out. But in such cases, when only sides, you should at least try exploring. It may or may not solve the question, but at least it's definitely a good alternative to consider in case you're not able to strike the question within like the first 1 minute and you're sort of uh, stuck on it. So just to keep in mind, right? So rectangle, again, this was 2 units. So this is 8086, 2 units to the left. So this would be 66 because same vertical level. There it is there. So then this line becomes x equal to y because 0066, it is clearly visible x equal to y. So this would be 88 and this distance is 822. So to demonstrate that only, like I've added this question here. That medians xa, yb of a triangle xyz are perpendicular. So there's a right triangle. So why right triangle? Because one angle is given as 90. Yxz, this thing is 90. This is 90. Xy equal to 8. Okay. Xa and yb are perpendicular. So xa and these are both medians. So this is midpoint, this is midpoint. These are also perpendicular. Xy equal to 8, find yz. Here yz. Now if I had to do it by the geometry route, and it's important to know this because like traditionally you start figuring out the geometry route for it, right? Now the method for this would be, in terms of geometry, would then be okay. You'll say that these are medians, we know that this will be half of this. And so basically this is the hypotenuse which you need to find. Okay, let's say, let me take this as some length, which is P. So I know that, okay, that this point is equidistant, like this is P by 2, this P by 2, this also is P by 2. This we have covered, right? That the circumradius, this is the circumradius, the line joining midpoint of hypotenuse. So this will also be P by 2. So that can be figured out. Then there'll be like 2/3 of this you'll have to take, apply Pythagoras in this triangle to figure out this length. Or to like make equations in P and Q, because you don't have any sides given. Essentially, you have one side given, but you don't have median lengths given. So you'll have to use the 2:1 thing. You then have to use this 90 degree for the perpendicular, like Pythagoras theorem as well here. And you need to use the fact that, okay, if this is like this is P by 2, this is P by 2, this is also P by 2. So 2/3 of this that length you'll have to apply Pythagoras here and then like proceed with the question there. Right. So that is one way to do it, but it will take time. So once I realize that, okay, I don't have the necessary parameters to really do that quickly, I should immediately see that, okay, it's a right triangle. So it's at least a relatively convenient diagram, right? So if I take this as 0, 0, if I take this as 0, 8, right, and because it's a right triangle, so like this would also be an x-axis. So this would be something like something comma 0. Let's take a comma 0. So if I get k, I'm done with the question, because this is then just distance formula. Correct. So now this is 0, 0, k 0. So what will this be? This will be nothing but k by 2 comma 0, midpoint formula. What will this be? This will be nothing but k by 2 comma 4, again midpoint formula. So on this line I know the 2 points, on this line I know the 2 points. I can multiply the slopes to be -1, find k and get the answer. Let's do that. So slope of this line would be nothing but 4 minus 0 upon k by 2 minus 0. So which is 4 upon k by 2. This is the slope of this into what is the slope of this median? So 0, 8 and k by 2, right? So 8 minus 0 is 8. 0 minus k by 2 is minus k by 2. The product value should be -1. Why -1? Because medians are perpendicular, which is given. So product is slope is -1. So this is nothing but 8 by k into 16 by into -16 by k equal to -1. So k is 16 into 8 is 128. So k is root 128. So this point is nothing but 8 root 2 comma 0. I know this point, I know this point. The simple distance formula gives me 8 root 2 square. So 8 root 2 square is 128, 8 square is 64. 128, 64 is 192. So 192 is 64 into 3. So this will be 8 root 3. And that is your answer for length of YZ. So this funda makes the question shorter. So just good to sort of have that concept of, okay, even if I know the full method, can coordinate geometry make it simpler, especially when these are when like sort of These are the figures getting made, and the most like the dynamics are in terms of side length. On that note, actually, one more concept you should know that's not directly related to coordinate geometry, but since we were covering this question, so just to know one more useful property is that pretty sure more than 95% candidates may not know for perpendicular medians. We had covered in triangle, right, that the area of the triangle is 2 by 3 into product of median sin theta. So that we've covered. There's another property which only like works in case of perpendicular medians. This is median, sorry, for not 90. Basically, if this is a median and this is a median and these two are 90 degrees, basically it's the midpoint, it's the midpoint. So, like from our discussion on triangles, we know that the area of this triangle would be if we are given the lengths of AM and BK, let's say. So it will be 2 by 3 into AM into BK into sin 90, sin 90 is 1. So 2 by 3 into M into BK. We can find the area if we are given the lengths of these two medians. That is one part. The other part, if in case medians are perpendicular in any triangle, always remember, and the triangle itself does not also has to be right. It can be any general triangle. Like actually should have made a general triangle. Let me just right. If in any triangle the medians are perpendicular. Okay, so like this side is small a, this side is small b, this side is small c. So you should know that wherever the medians are falling, so the one median is falling on A, so A square, the second median is falling on B plus B square will be equal to 5 times C square. This is a relation that you like, it may be useful to know in case of perpendicular medians for any triangle in the world. This is derived using 2:1 funda again, like where the medians are meeting, so it will divide the median into 2:1 as we've discussed for centroid and triangles, right? But this is the result that comes basically that on the side where the medians are falling, the sum of squares of those sides, a square plus b square, would be equal to 5 times the square of these remaining sides. Although here we couldn't have used that because we don't even know the second side. We know only one side. Like we could have used that, but it would take time to derive. So do make a note of this, like it can immediately come of use at some point. But yeah. Cool. And again, these sort of things are like, okay, like if you see a particular scenario, it will, now that you've seen it, it will immediately hit you, okay, medians are perpendicular, I can immediately, apply that. So saves you time. Cool. So again, geometry, was a better alternative here. Okay, this clearly is a coordinate geometry question. Find coordinates of foot of perpendicular from 2, 3 to the line 2x plus 3y equal to 12. The foot of perpendicular is basically the end point of that perpendicular, and it's a perpendicular line. This is the keyword. So if we have a line like 2x plus 3y equal to 12, this is point 2 comma 3. Find the coordinates of foot of perpendicular. So you draw a perpendicular. This point would be the foot of the perpendicular. Let's say M. So let's call this H comma K. This is 2, 3. This is 2x plus 3y. You need to find the coordinates of this point. First things first. What, like from the concepts that we have studied, right? What like which all do you think would be applied here? So first of all, I know that this is the equation of the line that is given. I know that there should be a line perpendicular to this, which means I should be able to know the slope of this line because I already know the slope of this line. The slope of this line is minus 2 by 3. I should know the slope of this line. How? Because minus 2 by 3 into m2, as we just discussed, will be minus 1. So m2 will be equal to 3 by 2. So I know the slope of this line is 3 by 2 of this perpendicular. And I know that there is a point on this line which is 2 comma 3. So I know a point on this line 2 comma 3. I know the slope of this line 3 comma 2. Equation is can be formed now. So y minus 3, which is this 3, upon x minus 2, which is this 2. So y minus 3 or x minus 2 will be equal to the slope, which is 3 over 2. So say that 2y minus 6, 3x minus 6. So basically this means that 2y equal to 3x, and after this point you're basically after this point you're basically done, because now you have this equation of this line which is 2y equal to 3x, or if you want to like be really technical about it, y equal to 3x by 2. So this is the y equal to 3x by 2, and this line was 2x plus 3y equal to 12. You can solve these two lines and get this point down, right? So like wherever these two lines meet, the point can be obtained by just solving these two lines. You put y equal to 3x by 2 here, so it will be 9x by 2 equal to 12. So 13x by 2 equal to 12. X will be 24 over 13. Y would be 3 times of this, so 72x by 36x by 13 actually. But you know, this is just calculation, but you know the process now of it, right? So this was the point and this was the line. So we first found the slope of this line because the perpendicular was involved, so we needed the slope of this line as well. So this slope of this line would be 3 by 2. Why? Because minus 2 by 3 was the point. So minus 2 by 3 into 3 by 2 is minus 1. So that's why this, and then just equating the slope by minus 3x minus 2 should be equal to the slope, because any general point if you take, this would be the equation of the slope, right? And then it's just a linear equation problem. So this is done. Three vertices of a parallelogram are this is this. This is a sort of a they used to ask this before because there's a single catch to it. Otherwise, the problem will go pretty long. So that's why nowadays they don't ask, because maybe people have figured it out or something. But yeah, whatever. So A, B, C, D is here. Now the first things first. Now we need to. It says that it's a parallelogram. So okay, so that we know. But where do these points lie? So again, it's good to just have a view of what the parallelogram looks like. So the first point is 1 comma minus 2, which is 1 comma minus 2 will be somewhere here. Let's call this point as A. So this point. 3 comma 6 would be somewhere here. 5 comma 10 would be somewhere even like beyond this. 5 comma 10. And fourth vertex we don't know, that is what we do have. But we know that the parallelogram that is going to be formed will be something to this shape. Something of this shape. Again, why am I doing this? Because I need to ensure that what is the sequence of these vertices is important. Here, coincidentally, like they are falling in the same pattern, so it does not really matter. Right? But if let's say the same question had given the question as 1 comma minus 2, 5 comma 10, and 3 comma 6. Instead of this order, if they had mentioned this sequence in the question, then it would be different, right? Because you would know that, okay, what is given is not in order, so I need to make them in order. Here, coincidentally, they are already given in order, which is why it's always helpful to have a visual of like what is the sequence of these vertices. You need to find the fourth vertex. Multiple ways to do it. There's a longer and there's a shorter way. The longer way to do it is, you know that the opposite sides in a parallelogram are equal, right? So what will you do? You will take this point as, let's say, xy. You will find this distance by distance formula, equate this to this distance you know, because these points you know, 3, 6, 5, 10, you know these points, right? If I just name them. So BC you know, AD you can make in terms of x and y distance formula, you can equate them. So that will be one equation in x and y. The other equation will be what? You know this distance, you know this distance. That will be the second equation in x and y, equating these two because opposite sides in a parallelogram are equal, as we know. So two equations, two variables, you can solve them. So that is one way and a very lengthy way to do it. The other way to do it, the quicker way to do it, is for a parallelogram. We know that diagonals bisect each other. Right? Bisecting means basically that wherever they meet, so it breaks down this into half and this into half. Correct. We know that this property is there for every parallelogram, whether it's a rhombus, rectangle, square, any parallelogram, the diagonals will bisect each other always. So we know that this basically diagonal and this diagonal will bisect each other, which is to say that the midpoint of both these diagonals should be the same. If I call this point as O, the midpoint should be the same. So if I calculate the coordinates of O from AC, because I know the points here, so it will be what? 1 plus 5 over 2 and minus 2 plus 10 over 2. So which is nothing but 3 comma 4. So I know that this point is 3 comma 4. Use this point now to find out this line. So basically then from B and D we'll have 3 plus x by 2 equal to the x coordinate, which is 3. 6 plus y by 2 will be the y coordinate, which is 4. So this gives x as 3. This will give y as 2. So just figuring out the midpoint of this diagonal essentially, because using the property that diagonals of a parallelogram by bisecting, so that midpoint should be the same for the other diagonal as well. So both diagonals should have the same midpoint. That is what bisection means. And just directly use them to get the points at the other corner, which are 3 comma 2, and you're done with the question. like if you got this question in an exam, it's an almost an oral question. You can just see that okay, 1 and 5 create 3, minus 2 and 10 create 4. So 3 comma 4 is my point. Now 3 and something should give me 3, so 3 and 3 will give me 3. 6 and something should give me 4, so that will be 2. So 3 and 2 is the answer. And even if it was a, like, let's say if they had asked that 3 vertices of a rhombus are these, find the fourth vertex, exactly same process, because even the diagonals of a rhombus bisect. Even if they are that is for a rectangle, for a square, the same process. Points 2, 1, minus 3, minus 4 are opposite vertices of a parallelogram. If the other two, okay, now here they are saying that those are opposite vertices. So we don't need to check like what is the sequence and all, because they are already saying that it's opposite vertices. Right. So A, let's say, is 2 comma 1, and B is, or C basically, since it's opposite, so minus 3 minus 4. If the other two vertices lie on the line x plus y, x plus 9y plus c equal to 0, so which means this line is basically given as x plus 9y plus c equal to 0, find C. We just now covered that it's a parallelogram, diagonals have to bisect each other, right? So if I join this, the midpoint of this diagonal should be falling on, should be the midpoint of this diagonal as well. What is the midpoint of this diagonal? So this is 2 minus 3 by 2, so which is minus 1 by 2. 1 minus 4 by 2, which is minus 3 by 2. Right. So now this point will lie on the other diagonal as well. So just put those values in this equation, you will get it. So x plus 9y plus c equal to 0. X is, so just fit like it, because this point lies on this line. So this point should satisfy this equation. Nothing but minus 1 by 2 minus 27 by 2 plus c equal to 0. So this is minus 28 by 2 minus 14. So c is equal to 14. Very straightforward question. This is a CAT 2020 question. Just like basically relying on the funda that diagonals are bisecting. So basically the midpoint of this will also be the midpoint of this. Since it's the midpoint of this, so this point lies on this line. Since it lies on this line, so it should obviously fulfill the equation on this line. Right. So pretty much similar to the concept that we discussed earlier. And as we mentioned earlier, that even if it was, let's say, a square, a rhombus, or a rectangle, it's still a parallelogram. It should still be fulfilling that. Okay, find the area of the quadrilateral formed by x plus 2y equal to 8, 2x plus y equal to 8, and the coordinate axis. Two equations given, coordinate axis, which means x and y axis. Now, area of the quadrilateral formed by these lines. Now, first of all, I should know, right, that what is the quadrilateral being formed? Like, what is the shape being formed? For that, I will always have to draw the diagram for here, right? So again, previously we used to draw the diagram because you needed to check the order of the vertices, and then we could move in any order, it should be fine. Here we have to draw the diagram because we don't know what the shape looks like at all. Like we have covered, right? Like for in area questions, you need to break those down into figures that you know. But for that, you need to know, right, what is the area getting asked. So here to figure that out, let's say you have a coordinate plane. So let's first plot this x plus 2y equal to 8. As we covered, the fastest way to do it is just see the intercepts of this and join them. So the x-intercept of this would be, you put y equal to 0, so 8 comma 0. The y-intercept would be, you put x equal to 0, so it will be 0 comma 4. So basically here 0 comma 4. So it is this line. You can extend it obviously, but it is this one. So this line is nothing but x plus 2y equal to 8. 2x plus y equal to 8 would be what? So 2x plus y, the x-intercept would be, you put y equal to 0. So you have 4 comma 0. For y-intercept, you put x equal to 0. So you have 0 comma 8. So this is the other line basically, and you can extend it. So this is nothing but 2x plus y equal to 8. So now we know what those lines are. The question says find the area of the quadrilateral formed by x plus 2y equal to 8, 2x plus y equal to 8, and the coordinate axis, which is the x and the y axis. So what is the area common to these? So this line, the area would have been this. This line, the area would have been this, right? With the coordinate axis, the common area is this, correct? Like this line, area under the curve would have been like this entire piece. This line would have been this entire piece. Now, and then you have to take the coordinate axis as well. So the area, like the coordinate axis sort of bound this area. Otherwise, it would have been infinite. So then this is the common area that comes. So the first step is to identify what the common area is. If you get this only wrong, then yeah, there's like There's no chance of getting the answer right, basically, right? So first is identification of this area, which usually is typically, as you saw here, is pretty straightforward, right? It's not like you have like 3 or 4 other equations and then you're having to see the overlap or common area, or where this is meeting, that is meeting, etc. Nothing. Just 2 simple linear equations and coordinate axis. This quadrilateral we know. So do we really know this quadrilateral? So this would be 0, 0. This is 4, 0 as we see. This is 0, 4 we know. We still don't know this point, right? Can we find out this point? Of course, yes, because what is this point? Nothing but the intersection of these 2 lines. So it's this point is the intersection of x plus 2y equal to 8 and 2x plus y equal to 8. Why am I after this point? Because the other coordinates I know. And I know from the area of the quadrilateral formula that we covered, that matrix-based formula, right? That if I know all the vertices, I can readily find the area of the quadrilateral. So that is why I need to get this. So 2x plus y equal to 8. So if you solve this basically, then this could be written as 2x plus 4y equal to 16. If you subtract these, so 3y, so 3y equal to 8, so y equal to 8 by 3. You put it here, so it will be, x will be equal to 8 minus 2y, which is 8 minus 16 by 3, so which is 24, so which is 8 by 3. So this point is nothing but 8 by 3, 8 by 3. Let's just check if, like, it's always a good idea to just sanity check if these are, like, especially when it comes in fractions, if these are still, these should fulfill these 2 lines, right? So x plus 2y equal to 8, 8 by 3 plus 16 by 3 would be equal to 24 by 3, which is 8, so it satisfies this. 2x plus y, so 16 by 3 plus 8 by 3, again it satisfies this. Okay, so now we know that these are the 4 points. Straight away the area of the quadrilateral formula can be applied, and because we have the figure, so now we know the sequence. You can take any sequence. Let's say you start with the point here, this one, or you can start with the point here, whatever you wish you can take, but you should just mark it. So like, let's say if you take the first point here, the second point here, the third point here, the fourth point here, it's just important to like get the cyclicity of this correct, like which comes after what and stuff. But otherwise you can take anything. You can even take like 1, 2, 3, 4 sort of an anti-clockwise direction. But once you take one direction, you should just like write the number so that you, like, in the formula it doesn't get confusing as to, okay, what was x1, what was y3, etc. So area would be half matrix x1 minus x3. Let's just write the formula as well, so better this thing, x2 minus x4, y1 minus y3, y2 minus y4. So if this is my point 1, this is my point 2, this is my point 3, this is my point 4. So x1 minus x3 will be what? 0 minus 4. So minus 4. x2 minus x4 will be what? 8 by 3 minus 0. So 8 by 3. y1 minus y3 will be what? 4 minus 0, which is 4. y2 minus y4 will be what? 8 by 3 minus 0, so 8 by 3. Just cross multiplication to open this. So minus 4 into 8 by 3 is minus 32 by 3, minus of 4 into 8 by 3 is 32 by 3. Again, it's a absolute value thing. So basically this will be half into 64 by 3, or 32 by 3 is the answer. Because area cannot be negative, right? So 32 by 3 is the answer. That is the answer to this question. Any doubt? Again, plotted the lines first to know that what area is getting covered, because otherwise you won't be able to figure this point out. Then basically, yeah, just applying the quadrilateral, the formula, the area, the formula of the quadrilateral. So again, nothing outside of what we know, just that getting to the diagram was key here. Similar question and area enclosure question, but this time the equation are not like standard linear equation. It involved a mod, right? Y equal to mod of x minus 1 plus 2. The second line is given as x equal to 1, which is a very simple line, x-axis and y-axis. So these components are common. Even this is a simple line, but this just that instead of a traditional x and y equation, it's a modulus equation here. Okay, so area enclosed by these lines. Now, okay, before we get to this, right? So we know that the graph for mod x is this, right? That we know, right? Y equal to mod x as this graph. And the more you, so, and like y equal to mod x minus 1, this graph will be shifted by 1 unit. Y equal to x minus mod of x minus 2, it would have been 2 comma 0. This we know, right? If it was like y equal to mod of x plus 7, then it would have been the same graph would have moved to leftwards to 7 steps here, and this would have been like minus 7 comma 0. So this we know, right? And even if we don't know, we'll still look at a method where you don't have to know this, and still you'll be able to do this. But yeah, this you should know even from not only from a coordinate geometry standpoint, but also from a function standpoint whenever you cover the topic of functions, right? So yeah, a pretty basic modulus graph. And once you add a plus 2 here, which means that this graph gets lifted by 2, right? So basically, if it was, let's say, mod of x plus 7 plus 2, this graph gets lifted by 2. Because what is happening really, right? So y equal to mod x plus 7, if it was only till this point, you were getting a certain value of y. Now, for every value of y, you're increasing 2. Whatever was the old value of y, every new value of y would be that old value plus 2. So basically, this graph will get elevated 2 units upwards. The y thing will get increased by 2 units. So essentially, if we were to plot this graph, right, and again, maybe some of you already know this, but yeah, just for the sake of others. So basically, for this graph, this would be, we know that y equal to mod x minus 1 would have been this at 1 comma 0, x minus 1 plus 2 would be this. So this would be 1 comma 0, and this distance would be 2. So basically, what this means is that this point would be 1 comma 2. Any confusion on this point? So this point is 1 comma 2 because this got lifted by 2 units. X equal to 1 is the second line, which is a fairly simple one to draw. So this will be x equal to 1. X axis and the y axis. This is the x axis, this is the y axis. So what is the area enclosed in that case? This is the area enclosed. I know this point 0, 0. I know this point 1, 0. I know this point 1, 2. You can figure out this point essentially, but you don't even need to do that because this is a standard trapezium figure, right? This is parallel to this. The standard trapezium. So area of a trapezium we have already covered is nothing but half into sum of parallel sides. So what is the parallel side here? This and this are parallel. Okay, no, you need to figure out this point in either case because otherwise you won't know this side. So now what will be this point? Now this graph we know is y equal to x mod of x plus x minus 1 plus 2. We know this. So basically now this graph has two parts, right? One for x greater than 1, and you know how to open modulus, right? One for x greater than 1 and one for x less than 1. Or you can put greater than equal to, less than equal to, it doesn't matter. It's a continuous function. So this part of the graph is basically corresponding to y equal to like mod x minus 1 plus 2 such that x greater than 1. So for x greater than 1, the equation would become x minus 1 plus 2, which is y equal to x plus 1 for x greater than 1. If x for less than 1, it becomes y equal to 1 minus x plus 2, because this will always be positive because it's a modulus, right? Modulus is always positive. Now, x less than 1 would make it 1 minus x. So 1 minus x plus 2 would be 3 minus x. So essentially, which is what like I was getting at, right? So I just told you that even if you don't know this graph, there is a way to sort of derive it. So you know that for x greater than 1, the line would be y equal to x plus 1, which is this line. For x less than 1, the line would be 3 minus x, which is this line. So this part of the graph is nothing but y equal to 3 minus x. This part of this graph is nothing but y equal to x plus 1. The critical point being 1. How do I know this is a critical point? Because the modulus critical point is 1. If it was, let's say, for example, y equal to mod of x plus 5 minus 3 minus 8 or something. So here the critical point would have been minus 5. So you would have a similar graph for x less than 5. It would, so for, let's say if it was this equation for x less than, so the critical point is this. So you have to see the value of x on both sides of this. So for x greater than minus 5, it will still be x plus 5. For x, okay, since it's a plus, so the modulus won't change. In both cases, it would be x plus 5. But essentially, since this has to be a positive number, right? So basically, you would have to say that, okay, if it is x plus 5, then whatever gives the positive. If it is less than minus 5, let's say it is minus 6, right? So minus 6 plus 5 would be negative. You cannot have a negative mod, right? Minus 6 plus 5 would be negative, right? So you should have a positive mod. So you have to adjust the content of the mod as per like what gives you a positive result and then make those equations and solve. Like here we did the x minus 1 and the 1 minus x. So just see around the critical point and make those two equations and you can draw. Otherwise, if you already know how to draw the mod graph, you can just directly plot it. So this part of the line is y equal to 3 minus 6 and this is x plus 1. So this point now I can find out because this is 3 minus x and this is, what was this point? This is nothing but x equal to, okay, this is nothing but origin line, right? So yeah, so this is nothing but the origin line. So where does this line cut? These are the main axes only, right? So yeah, so what will be this point if this is y equal to 3 minus x? This will be 0 comma 3. So the points are 0 comma 0, 0 comma 3, 1 comma 2 and 1 comma 0 here. You can find the area of the triangle, area of the quadrilateral by the quadrilateral area formula, or you know that it's a trapezium because sides are parallel, so it will be half into sum of parallel sides into height. The parallel sides now you know one is 3, the other is, this height was 2, so this is 5 into height. Height is nothing but distance between the parallel sides, so distance between parallel sides is 1, so this is 5 by 2 or 2.5, and you're done. So essentially the only like working part of this was to figure out this graph and then figure out this point. Obviously the graph, since it's not a like a continuous line, it will have a different equation for this part, a different equation for this part every time. Correct. X minus 7 mod plus 5 would have a, like for x greater than 7 it would be x minus 7 plus 5, for x less than 7 it would be 7 minus x, and those cases are okay. So for example, for the example that we were discussing here, if it was y equal to x plus 5 minus 8, and please like sort of get this absolutely clear because it will be of very much utility even in functions and stuff. If x is greater than 5, then okay, then this will anyways be a positive number. So it will be x minus 5 plus x plus 5 minus 8. But if x, so the critical point here is minus 5, right? The critical point is minus 5. If it is greater than this, then it would be the same form. If it is less than minus 5, then it's clear that this entire thing would be negative. So you'll have to take minus x minus 5 minus 8. So this x plus 5. So basically mod of t, basically if t is positive, it will stay as t. If it is t is negative, it will become minus t. That's the whole concept of it. That's it. So the moment you see that this is becoming negative, just take the negative of this thing. So x plus 5 ka negative would be minus x minus 5. And you're done. Okay, maybe you would have known all this, but yeah, just for this question, it's always good to have that.